We talked last time about our special parallelograms. Our special parallelograms are our rectangle, our rhombus, and our square. And today in lesson 6.5, we're going to talk about the conditions that need to be met in order to be one of those special parallelograms. And we're going to later look at proving that our quadrilateral is either a rectangle, a rhombus, or a square. So let's start by reviewing some conditions for our rectangles. For our rectangles, it says that if one angle of our parallelogram is a right angle, that is enough to prove that we have a rectangle. So as long as I know I have my parallelogram and one angle is 90 degrees, we know that all four would have to be 90. It's going to be a rectangle. Box 2. If the diagonals of your parallelogram are congruent, that is enough to prove that we have a rectangle. So if I know here I have parallelogram, if I know that AC is congruent to BD, that would prove rectangle. What about conditions for a rhombus? Well, one condition says that if you can prove one pair of consecutive sides to be congruent, then your parallelogram is a rhombus. One pair of consecutive sides congruent shows that we have a rhombus. So looking at my diagram over here, I can see parallelogram, opposite sides parallel. Consecutive sides, they have marked this side, side EF and side EH. They are consecutive because they're side by side. That would be enough to prove I would have a rhombus. That would essentially mean because opposite sides are congruent that all four would be the same. Looking at the diagonals, if the diagonals of our parallelogram are perpendicular, then the parallelogram is a rhombus. We already know that they bisect if it's a parallelogram, but specifically if they meet at 90 degrees, it has to be a rhombus. And lastly, in box 3, if one diagonal of the parallelogram bisects a pair of opposite angles, then the parallelogram is a rhombus. So I can see in this diagram here, these markings are showing me that that diagonal isn't bisecting the angles. That would prove I have a rhombus. So how do I prove that I have a square? Well, we know that a square is a rectangle because it has 4 right angles, and a square is a rhombus. It has 4 congruent sides. So in order to prove that you have a square, you must prove that it is both a rectangle and a rhombus. Okay, in example A, they are going to ask us to do some investigating and to decide if our quadrilateral is best named as a parallelogram, a rectangle, a rhombus, or a square. Now we know that some of them could have more than one classification, but we want to pick the best classification. So as I look at diagram 1, sometimes the markings are kind of hard to see, so I'm going to go ahead and darken them for you. I sometimes will start down the line by determining, can I say it's a parallelogram? And I would say, yeah, my diagonals here are showing that they bisect each other. That would mean parallelogram. Can I say that this is a rectangle? Well, because I have my right angle, one right angle means four right angles. Yeah, it's going to be a rectangle. I do not know that all of my sides are congruent, and so I can neither say rhombus or square. My best choice then is going to be rectangle. Taking a look at picture 2. I look at picture 2, I'm going to darken the markings for you. What is it showing me? Well, can I determine it as a parallelogram? Yes. My diagonals bisect each other. Can I determine rectangle? No, I don't know that I have any right angles. And if it's not a rectangle, it's not a square. Can I determine that it's a rhombus? Do I know anything about my outside segments? Well, even though they look close to being the same, I cannot prove that. I do not know for sure. So I am going to have to go with parallelogram. Picture 3. In picture 3, do I know it's a parallelogram? Yes, my diagonals bisect each other. Do I know it's a rectangle? Well, in fact, these diagonals are going to be congruent based on the markings. Do I know that this is a rhombus? Well, my diagonals meet at 90 degrees. Is it a square? Well, because it was a rectangle and a rhombus, yes, my best classification here is going to have to be square. Okay, let's take a look at example B. In example B, they ask us to use the diagonals to determine whether a parallelogram with the given vertices is a rectangle, a rhombus, or a square. Choose the best classification. So we see we have the coordinate points P, Q, R, and S, and we do have a graph. Let's go ahead and label P at -1, 4, Q at 2, 6, R at 4, 3, and S at 1, 1. We know our diagonals. We're going to use those diagonals to determine whether it's a rectangle, a rhombus, or a square. So my diagonals that I'm looking at are PR and QS. How do we know? How would we know based on our diagonals if we have a rectangle? Well, we said that our diagonals would have to be congruent in order to be a rectangle. If it is a rhombus, our diagonals would have to be perpendicular. What about square? Well, to be a square, we said we have to prove that it's both a rectangle and a rhombus. So those diagonals would have to be congruent and perpendicular. Now the question is, how do we prove congruent? Well, you may remember from the last lesson that graphed on the coordinate plane, when we're looking at proving congruent, we used the distance formula. So I'm going to take my diagonal PR, and I'm going to use my distance formula. We're going to set it up like so. I have to be careful that I'm using my coordinates for the diagonal PR, so maybe I'm going to go ahead and I'm just going to highlight them. I'm going to be using my numbers highlighted in yellow. So distance formula, x minus x, and over here in these parentheses, y minus y. And then we're just going to go ahead and simplify. Looks like we're going to have 5 squared and 1 squared with a length of the square root of 26. Now I can leave it like that. I know that this is roughly maybe going to be about 5.1 when we type it in on our calculator. We can leave it in radical form because we're just going to go ahead and come over here and now check for QS. QS, I'm going to be using these two coordinates. And so again, I'm going to set up the same thing, distance formula, x minus x, quantity squared, and y minus y, quantity squared. 1 squared, 5 squared. Okay, so square root of 26 and the square root of 26, we can say, therefore, we know it's going to be a rectangle. Now, am I done? Well, not necessarily, because I still need to check. If I have a square, it would be both a rectangle and a rhombus, so I do need to check whether or not it would work for a rhombus. Rhombus, we're saying perpendicular. Well, last time we said if we wanted to show perpendicular or to prove, we would check using the slope. So I'm going to go back to my diagonal PR, and I'm just going to go ahead and look at the slope. PR, my slope, I'm going to do y minus y over x minus x. And then I will check QS, y minus y, x minus x. Okay, so I have a slope of 5 and I have a slope of negative 1/5. We then, therefore, can say that we have a rhombus. Well, if I have a rectangle and I have a rhombus, I know that the best classification for this is going to then say we have proven we have a square. Okay, if you have further questions on this, please feel free to stop in and see me.